Hey guys, I'm gonna show you something real quick. Cool little experiment to prove to us why when we have a lot of acid buildup in our stomach, right, and our stomach's hurting and things like that, why milk of magnesia works. And there's actually a lot of cool science behind it, all right? So what I'm gonna do to kind of start us off here is I have a beaker right here, and I'm gonna fill it pretty generously with red cabbage juice. Okay, this is not Gatorade. Red cabbage juice and maybe a little bit more. Okay, and you guys can see the nice color we have there. And what I'm going to go ahead and do is I'm going to put in some milk of magnesia, and you can see some flakes coming off. That's because I haven't used it in a while. And actually, milk of magnesia before you ever use it, you should shake it up because milk of magnesia is not soluble in water. It doesn't dissolve in water, so when you first open it, you'll notice that there's a bunch of water on the top and then a bunch of white stuff underneath it. Um, that's because, and that's going to be important for us to remember. So look at me. Milk of magnesia, non-soluble in water. When you first open a bottle of milk of magnesia, you'll see that there's a layer of water on the top. That's because the milk of magnesia doesn't dissolve in water. And you'll notice somewhere on the directions it says that before you serve it to the unfortunate person who needs milk of magnesia, poor person, tells you got to shake it up pretty good. Okay, so I did that. I'm gonna pour some in here. Pretty generous with it. Doesn't really matter how much, I guess. All right. So I'm pouring it in, and you'll notice we got some pretty cool colors going on there. All right, I'll mix it up. Mix it up here. Okay. So we got a kind of like a milky green color to it. That's great. Something I want us to notice. Let's make some observations about this fluid real quick. It looks kind of thick. Kind of looks like one of those Shamrock shakes. I don't know if McDonald's still does that, but around St. Patrick's Day they always have a green milkshake thing. It's really good stuff. But that's what it kind of looks like to me. I can't see through it. It's not transparent. It's just like a thick liquid. What I'm going to go ahead and do is, this is symbolic of, what's going on in our stomach, right? We have milk of magnesia. Milk of magnesia turned green, so we know milk of magnesia can't be an acid, right? Because with red cabbage juice, if it were an acid, it would turn red or pink. If it's a base, it's going to turn blue or green. And it turned green, so we know that milk of magnesia, it's not acidic, it is basic. Now I'm going to go ahead and do, to represent the acid buildup in our stomach, I'm going to start adding some acid. And the acid I'm going to use is actually the same acid that's in your stomach called hydrochloric acid. It's really stinking strong. And if you've ever, had acid reflux, or if you've ever thrown up, puked, right, your throat, it burns. That's because some of the stomach acid, the hydrochloric acid, is coming out of your stomach through your esophagus, and you can kind of feel it in your esophagus burning. If you have too much of that in your stomach, that's a problem. Sometimes it can burn some holes in your stomach called ulcers, and just not good. All right, but we're gonna keep this in the beakers. All right, we're gonna keep this in the beakers today. And I do want to say beforehand, I did not get this from a stomach. Okay, you can order hydrochloric acid. All right, it's a pretty common chemical. It is found in your stomach, but doesn't mean it came from a stomach. So let's just get that out the way. So I'm gonna go ahead. I'm gonna add some drops of hydrochloric acid, and we'll start making some observations of what's happening as we go here. Okay, so I'm noticing some color change. It looks like it got darker. It was pink for a second. I'm gonna add some more. Okay, looks like it was pink, right? So it was acidic for a second, and then it went right back to being blue. Let's keep trying this. Okay, so it's pink. goes right back to being blue. That's exactly what's going on in your stomach when you have milk of magnesia, right? You have that acid buildup, but the milk of magnesia keeps it from staying acidic, okay? So when you have a lot of acid buildup in your stomach, you want to take milk of magnesia because it's turning that acid in your stomach into a base. But I want you to notice something. I'm going to keep trying here, and I'm going to stop using the pipette, and I'm just going to start pouring this stuff in. I want us to notice something as we go. Okay, so very bright. Oh, hang on, it's going back. Now it's purple. Now it's purple. Looks like it might be going back to blue now. All right, fair enough. I'll add some more. Let's see what we got. Oh, going back to red. It's going to go back. Is the milk of magnesia going to do the job? Let's see. It's the milk. Okay, so this is pretty frustrating. I'm kind of stuck wondering right now, why is it not turning back to blue? It was in the beginning. I want you guys to take a look at this real quick. Do you remember when we started and we had a really thick liquid that was non-transparent? Couldn't see through it. Well, this now, I know it's hard for you guys to see, but if we were to look at this carefully, this is pretty transparent. I can actually see through the liquid in here. I don't know if you can. Let me see if I can. Maybe if I put the stirring rod in there. Can you see the stirring rod through that solution? You can still see the stirring rod in the solution there. Okay. So my question is, at the beginning, we had this really thick substance that we couldn't really see through. Okay, and that was because of the milk of magnesia, right? The milk of magnesia was kind of like a milky color. It made it thick and hard to see through. Once I started to add the acid, you could see the milk of magnesia and the acid were kind of fighting with each other, right? So the acid wanted to stay, it wanted to keep it red, but the milk of magnesia was fighting back and turned it back to being blue, turned it back to being basic. And then it took a few rounds until I lost my patience, and I just poured a whole bunch in, and then it stayed acidic. The reason it stayed acidic, we can assume, is because maybe the milk of magnesia ran out. That would be a good theory, right? Like, we could say, well, the reason, it's not like the milk of magnesia just got tired and gave up. No, the milk of magnesia ran out. And we can prove that too, because we talked about how we can now see through this liquid now. We can see through the red. We can see the stirring rod through the liquid. That tells us that the milk of magnesia went away. It ran out, okay? Now I'm sure I'll go ahead and try and add some more. What would happen is, if I do that, I'm as curious as you guys are to see this. If I stir it back up, looks like it's getting a little bit darker. I don't know if I added enough. You can see at the bottom it's starting to turn a little purple, but I think if I add more, my beaker is going to overflow. But, oh, hang on. I guess it takes patience. We're starting to get purple again. Okay. And if I added enough, you would see, and I'm looking through the top, it doesn't look like I can really see the, can't really see the stirring rod through that liquid anymore, okay? That's because the acid and the milk of magnesia reacted with each other until the milk of magnesia completely went away. So in this case, we can't necessarily say a new substance was formed, but we can't say it for sure, okay? But we can assume that it happened. But we can 100% say that there is a substance that disappeared, went away, right? But we'll talk about the word disappear, because do things really disappear in chemical reactions, or does that happen? That's what we're going to talk about next video, okay? And we're back to being blue again. Milk of magnesia 1. All right, that's what I'm talking about. Good job. Okay, we'll talk to you guys next video.